Welcome to the AI workshop, Meet Your New Fitness Trainer Muscle AI. Thank you so much for joining us. About this workshop, you will learn how to classify different physical motions and body positions using SparkFun, Micromod Machine Learning Carrier Board, and the Nordic NRF 52840 Micromod Controller Board. You will collect and train your machine learning model using Edge Impulse, and finally, you will deploy your own custom model back to the hardware and integrate it with free Nordic mobile phone tools and get the data off the board for useful development. My name is Cassie. I am typically the person that is behind the camera. Today, I will be your MC and be helping out with all the controls, with all the switching. And we are so excited to have all you guys here. Thank you so much for coming out. And I hope you've gotten all of your kits and got everything all downloaded. If not, that's okay. This recording will be available for you guys afterwards. So if you miss anything or you have trouble, you can always go back and go through it. We have two great speakers today. We have Peter and Louis. They're going to be talking with you guys about the board and everything Edge Impulse and Nordic Semiconductor. We are so excited to have them here with us. Thank you so much for already commenting on. I was going to ask where is everybody from, but you guys have already kind of started that. I am looking over at the feed, answering any questions I can, and I'll relay them over to Peter and Louis once we get started. And yeah, I'm excited for everything to be going on. I will put on some links in the comments for you guys. Any added links to help out with any of the content. But anyway, I'm going to pass it off to Peter. He's going to talk to us a bunch about Nordic, and here he is.
Thank you, Cassie, for that great introduction. Really excited to be part of this workshop together with Edge Impulse and SparkFun, and great to see that so many of you have signed up and is interested in this. So my name is Petter Myhre. I work for Nordic Semiconductor. I'm head of product marketing over there. I've been with Nordic for 8 years now. So I lead a small team here, taking care of the broad marketing efforts, webinars, blogs, website, and all the content to give our products the right promotion. Yeah, maybe Louis, you want to say a few words about yourself as well?
Sure, thank you, Peter. Thank you, Cassie, for this introduction, and all of you for being here. Well, the 250 seats has been taken so fast. This is great. So my name is Louis Moreau, and I'm a user success engineer with Edge Impulse. I am an engineer, so I graduated in 2016 as a telecommunication and computer science engineer. I've been in the IoT world since. I started my career developing small GPS trackers for rhinos, and so I've been to Africa to test actually this project in productions. Then I moved to another company a few years later, focusing mainly on container-based and IoT platform products. And now I joined Edge Impulse as a user success engineer, and we are 5 people in the team. One of my colleagues, Aurélien, is here in the chat. Otherwise, you can reach any of us on the forum. We try to respond within a day, so forum.edgeimpulse.com. And yeah, happy to be here. So I'll be your instructor during the workshop.
Awesome. Well, thank you so much. You guys, thank you for introducing yourselves, and we're getting started first with Petter.
Thank you. Then let me just say a few words about Nordic Semiconductor before you can get your hands dirty with the actual workshop. So maybe you are familiar with Nordic already, but I want to say a few words quickly, give a Nordic at a glance. So we are enabling the IoT, and we are a fabless semiconductor company where we work in the IoT space, and we specialize in low power wireless connectivity. And we are an old company in this space, actually. We were founded in 1983. And actually now we have reached an important milestone with more than 1,000 employees. And we're also looking for more people. So please have a look at our ads. I think Cassie will share a link to that. Yeah, and We're the market leader in short-range IoT. So actually, we ship more than 1 million Bluetooth Low Energy SoCs every day now. And in 2020 alone, our customers certified more than 500 new end products. So I'm really happy about that. And when I talk to customers and they ask them why do you select Nordic for your product, I mean they say that we offer really high quality system on chips, and we have really low power consumption. And then our protocol stacks, from, for example, the Bluetooth Low Energy protocol stacks, have excellent interoperability with the smartphones and tablets out there. And then we have the easy to use software and tools as well that we provide together with our ICs, which you can see here. So we have a broad portfolio of ICs. We have both short-range ICs supporting Bluetooth Low Energy, Thread, Zigbee, Bluetooth Mesh, and so on. And we also are in the cellular IoT space, where we offer a very integrated solution, small, ultra-low power, of course, that's in our DNA. And we want to make it as easy as possible for the developers out there to make products with our ICs. So we provide software where you can use that with it contains drivers, examples, kind of everything that you need to build a product. And then we focus a lot on helping you with our development tools and excellent tech support through your development cycle. So just quickly, our product portfolio. So we have the nRF52 series. This actually have seven system on chips right now. We're gonna work on the high-end one today, the nRF52840. These are all based on ARM Cortex M4, running at 64 MHz. Then we also have the nRF53 series, which is our flagship device. This is a dual-core device, so it has two ARM Cortex M33s, one running at 128 MHz, the other one at 64 MHz. And then we have also the nRF9160, which is our low-power cellular IoT solution. This is actually a global device, so you can build a product that can be used all over the world. And it's very small and uses very little power. We also expanded into offering some complementary devices. So we actually have a front-end module, and recently we launched our first power management IC. So our portfolio is growing and exciting times ahead. So then over to the micro-mode nRF52840, which I hope you have in your hand now. It's called nRF52840 because it has Nordic nRF52840 system on chip inside. It's actually inside this RayTac module that you see in the middle here. So I just want to say a few words about that device so that you know what you have in your hands. So the nRF52840 is an advanced multi-protocol SoC, and it supports Bluetooth Low Energy, Bluetooth Mesh. It has NFC support, Thread, and Zigbee. So you can run actually multiple protocols at the same time. Typically, you run Bluetooth Low Energy together with a mesh networking technology like Bluetooth Mesh, Thread, or Zigbee. And you can run this on the same radio, and our chip will handle the connection, maintain the connections, and so on. And then if you have a look at the processor in there, it's a 64 MHz ARM Cortex M4 with a floating point unit and DSP instruction support. It has 1 MB of flash and 256 KB of RAM. Please note the amount of RAM here, because this is something that Louis will trail back to and talk about when he is building the machine learning models later, to show you how much of the RAM they are using. When it comes to the actual radio, this can have, it has adjustable TX power. You can have up to 8 dBm TX power. It supports the Bluetooth 5 2 megabit per second mode, in addition to 1 megabit per second. It also supports Bluetooth long range, so you can get that extra range and build products that covers the whole house, for example. It has 802.15.4 support with the thread and Zigbee and can run concurrent multi-protocol. It also has a rich set of analog and digital peripherals and interfaces. I'm not going to go through all this, but you can look at these slides later if you are interested, with some timers, RTCs, and all the common digital interfaces, UART SPI and 2-wire, also called I2C. It has a USB, a high-speed SPI and QSPI, and also an ADC, and it has 48 GPIOs. So it supports a wide range of different applications and products. Most relevant for today is sport and fitness and wearables, but it also supports a lot. It's used in a lot of different markets and applications out there. So that's a quick intro to the nRF52840. I think Cassie will post a link so that you can read up on it more if you're interested. But now I give the word over to Louis so we can start the exciting stuff.
Thanks a lot, Peter. Yeah, it is indeed a great system on chip. Let me share my screen and we will deep dive directly into the subjects. I do not have any slides. If you want a presentation of Edge Impulse, we have plenty of stuff already on the internet. What you need to know is that we are a platform built by developers and for embedded developers. So our goal is really to enhance our community to build real case application, well, real use case and real application using machine learning without being an expert in machine learning. So yeah, that's probably the few words I wanted to say about Edge Impulse. You will see how to use it in details during this workshop. I hope you will have fun. I had fun building this tutorial and this workshop, collecting the different motions, and you will do that as well. If for any cases you cannot run the piece of code on the device, this doesn't matter. I will give you the link of the public Edge Impulse project so you can clone it. And also, if you cannot run the inference or collect the data with this board, you can do it with your mobile phone. We have an option for that. I hope everyone will be able to manage to make it work, but otherwise we have a backup plan. So the first thing you will need to do is probably clone this repository. I don't know if you are familiar with GitHub. You can just download it or do a small git clone. Let me do that here. I will move to workshop, workspace workshop, and I will git clone here. Oh, it's already, because I already cloned it just before. Let me just remove that. Well, it doesn't really matter, in fact, if I already have it. Here, so let me just go through briefly the architecture of this repository. Here you have one folder that you will be able to copy paste to include this board to your Arduino IDE. Unfortunately, this board is not fully supported yet. You have to do some modification by hand. So I thought that having just a folder to copy paste would be easier. SparkFun is actually working on a fix so that you can add this board way easier. Second folder is all the Arduino examples. So there are 3 Arduino examples that we will use. One will be the data forwarder. So basically just plot in the monitor serial console all the accelerometer data so that we will be able to grab them using Edge Impulse Studio. The second Arduino example is the inference, how to run the inference once we will have trained our model. And then we will see in the, well, let's say a going further section, how to run the inference and send the results over Bluetooth. The assets you don't really need, it's just for the images of this repository. So the link, Cassie will share it, already has, it's here. So you can just get it and clone it directly on your laptop. And the EI library, if it's in case you cannot make it, well, you cannot compile your firmware. Here is my version of the Arduino library, which is the model compiled to be able to run on the Arduino IDE, and well, so that we can flash this code onto the board. The library is here. So what are we going to use? Obviously, we are going to use the SparkFun micro-mode machine learning carrier board and the Nordic NRF 52840 that Peter just presented. So we are going to go through all those steps, which are installing the dependencies, collecting the data, then training your machine learning model, which will be a mix between digital signal processing and machine learning blocks, and we will see how to make it work together so that we can have a very good precision. Then we will see how to run the inference on the targets, and then, as I said, send the inference results over Bluetooth. Between each of the sections here, I'll pause, and Cassie will share me some of the questions in case you have any troubles. Note that Aurélien as well is in the chat from my team, and he will be able to debug you in a real time, hopefully. Yeah, let's get started. So I hope, well, you had some prerequisites to do, which were installing the Arduino IDE. I recommend to use the Arduino version, or Arduino IDE version 1.8.15. I tested on both Mac OS and Windows. I haven't tested on Linux, but it should work just the same. Then you've been asked to install the Edge Impulse CLI, and for that you need to have Python installed locally and Node.js with a version higher than 14. If you haven't done so, no worries, you can do it right away. Otherwise, this tutorial won't change, and you will have the replay afterwards. And last but not least, you need to download from the app stores or the Google Play the Nordic Semiconductor NRF Connect app, so that you will be able to see the inference results on your phone. So yeah, let's get started. Let me open my Arduino IDE. So here, let me zoom in a bit so you can see better. So in my case, I already have the SparkFun board. If you go to Tools, Board, Arduino, Embed OS, and SparkFun. So I will just remove it so we can add it together, which probably is the hardest part of this workshop. So let's go to Arduino Preferences. Then you have a link to directly open the application folder here. So it is here. Then if you go to Packages, Arduino, Hardware, then you have the embed thing. So I will delete everything concerned in the hardware folder. Let me delete all of that, and I will restart my Arduino IDE so that you can see that I will be at the same step as you and Arduino. As soon as you change anything in the actual application folder, you need to restart your Arduino IDE. When you add the board, normally you do not need. Same for adding a library. So yeah, here it is. So as you can see, I do not have any other board than the Arduino official boards here. So to do that, to add the board, I will just so go to, again, Preferences and open the application folder. You can go, oh, so I already had it open, in Package, Arduino, Hardware, and then as it's empty, what I will do is just copy paste from the document I just opened, from the folder I just opened, which is the GitHub, basically the GitHub folder. Here you have the board, and you can just copy this and paste it in the hardware section. Note that if you do not have the same structure, you might need to install a board. I will show you how to do that. Meaning, like, if you started from a blank, from scratch, or if you just downloaded the Arduino IDE, you might not have this structure. So here it is. I've got that. So if you didn't have this structure, you can just go to Board Manager, and then type embed, just embed. Let's look for it. And you need to install this one, which is deprecated, and select the version 1.3.1, which is already installed right now. Yeah, this is a bit annoying, but as I said, SparkFun is working on a fix. So someone just asked if I can go briefly over that piece again. Of course, I can go over. So yeah, if you just started from a blank, well, from scratch with as you just downloaded the Arduino IDE, just go to board manager, and then install, look for embed. Then go to the deprecated package and select the version 1.3.1, which is already installed in my case. So closed. And then once you have installed it, you just need to copy paste. Also remove the embed folder and copy paste the new one that I just provided in the Arduino, in the GitHub repository. Okay, so now that I've done that, I will restart my Arduino IDE. Arduino. And again, everything should, I hope I've documented everything step by step. I guess you have all the things you need well, in here, in the README. So Arduino, here it is. And let me check if I have the board, Arduino Embed OS. And yeah, I do have the SparkFun micro mode board. So that was probably the hardest part. And yeah, so we have it. Now we were going to test to check if it actually compiles. So back to your folder, just go to the Arduino examples, and we will use the data forwarder example. So just open that up. Here you have it. So this is if I go briefly through the code, I just include some of the meaningful and libraries. Here you need to install that one manually. So for you to be easier, you can just click on this link. It will open a window, and it will filter directly the right Arduino library that you will need. So you just click on install, wait a few seconds, and it will be installed. Then if I go through this piece of code, what it will do is, so I set a frequency so that I can get the accelerometer reading every, well, X milliseconds of interval. So I just calculate that based on the frequency I want. Then for the setup, this is how to set up the serial monitor, so the serial console with the baud rate of 115200. It doesn't really matter if you don't understand all the steps. I will just explain them. If you need, you can go and dive deeper in it after. So yeah, here I just put some printing for debug. Then I initialize the wire. I set few parameters on the accelerometer. So here 2G, set the 8-bit mode, and then I put higher rates so that I can make sure I have every information that I need. So this is in the setup. So for those who are not familiar with how Arduino code is made, so you always have one setup and one loop function. So the loop will go over and over again, just like a while one function in a normal C++ or C code. And so in the loop, every MS interval, like an interval a millisecond. So every, well, I cannot do the calculation right now. So every few milliseconds, what it will do, it will just get the accelerometer X-axis, Y-axis, and Z-axis. So yeah, to upload the board, this sketch on the board. So for those who have troubles, I will just stop after this this section. So make sure you connect your board to your laptop, then that you have selected exactly this SparkFun board, and you should see on the port like one. So here it recognizes the Arduino Nano BLE because I just modified one of the embed library. So select this one. If you are on Windows, you should see something like port com, so com4, com5, well, com something. And yeah, so let me try to, let me first try to compile it, and we'll make sure everything works. It can compile as expected. Depending on your laptop, like I would say power, compilation can take more time. For example, here I had to disable Docker because it was taking a lot of energy on my Mac. So yeah, done compiling, and I will upload the sketch. And once done, I will stop for a few minutes so that I can answer your questions. Uploading the sketch. Here we are. 100%. So now, to upload the sketch, you just need to click on that little arrow on the upper left corner and to open the serial monitor to see what it is actually printing. So on the serial print here, you need to click on the serial monitor, which is on the upper right corner. So it's open on another window. So here it is. And you can see that if I move the board around, the information change. So great. Let me pause for a few minutes and get some questions. And yeah, happy to help. So Casey.
Yeah, thanks, Louis. Yeah, some people are still falling a little bit behind due to installing the boards from the repo, but luckily this will be available for them after the recording. I think you're able to now even scroll back from the live feed. Some people can go back if they need to. If you guys have any questions, just go ahead and throw them in the chat now. I know you guys want him to go over some of that briefly again, just like what we did previously for you connecting the boards up to Arduino. Some people are asking to kind of briefly go over that piece again that you just kind of showed us.
Oh yeah, sure. I can do that again. So to install the board, so you just need to go to Tools, Boards, Board Manager, and then you need to look for the embed. Just tap embed, and then you need to go to the very last one, which says deprecated. And here in this case, you need to go to the version 1. So this one, 1.3.1. Then you need to install the board. Once it is installed, you can go to your Arduino preferences, and here you have a link that will directly open the application folder. So when you click on that, it will open the Arduino application folder. I think I set it on the README. Just let me make sure. Yeah, so on Windows it's under local app data, Arduino 15 package, Arduino extra, OS 6 and Linux. So here, in case you cannot click on that. So yeah, once you have your application folder open, you can go to Packages, Arduino, Hardware, and replace this embedded folder that you just had by the one that is provided in the GitHub repository, which is Arduino board. You just need to copy paste this one and basically replace the other one. I hope that was clear. If not, I think you can roll back on the YouTube video. So next question. So let me quit that. Next question. Is there any way to store data with CSV formats? Yes, I think so I haven't tried, but on this board you have a dedicated space for micro SD, and you might need to install another library from Arduino, but yeah, you can definitely store this under. You might need to do some work around, but I'm pretty sure it's feasible. And then you can extract the SD card and then just play around with the CSV. Do we have any other questions?
It looks like that people are still kind of putting these together, but since this will be a recording, I think we're okay to continue on. And again, if you guys need to scroll back or follow it along once everything is ready, you will have the ability to do so afterwards. So go ahead, Louis.
Thank you, Cassie. So here we are. We just run the data for the example sketch, and we took some time for the questions. Now, second part will be collecting the data. So to do so, you need to have an Edge Impulse account. We'll connect to the Edge Impulse Studio. If you haven't created an account now, you can do that. Just go to edgeimpulse.com, and you can just sign up here or log in. In my case, I'm already logged under the rights account, and I will create a new project, which I will call Spark Fun Workshop. Create a new project. Okay. So when you have created a new project, you will have this small wizard like guiding through all the steps. So for example, here we are going to use accelerometer data, but you could use audio data or images or something else. Like we support almost any kind of sensors. Here I will select the accelerometer data, and it will guide you through different tutorial or links to our documentation. So yeah, let's get started. Now you arrive on this dashboard, which is basically an overview of your projects. One thing we will do is just select which kind of board we are using. So here, so this SparkFun micro mode board is not officially and natively supported by Edge Impulse. So we will choose one that has exactly the same microprocessor, so the NRF 52840, which is the Arduino Nano BLE. By selecting this, the Edge Impulse Studio will give you an estimation of the inference time, the DSP processing time, the RAM and the ROM footprint that will be needed to run on this specific target. So yeah, this is the only thing you need to do on this dashboard. And then I will go to the Devices tab. So the first thing I will do is to connect my phone, just in case any of you have troubles connecting this micro mode board and you still want to follow up doing this workshop with your phone. So to do so, you can connect a new device and you can show the QR code. So what I will do, let me open a new terminal so that you can see my phone. Here we are. Now that we are getting familiar, you get to know my baby. Here we are. Let me select the camera and I will flash the QR code. Of course, I forgot to remove the airplane. Here, device is connected. I do not. Let me do that again because it should open a new. Sorry about that. Yes, delete. I will delete them. Yeah, first bug. Let's do that again. Sorry about that. Here, Edge Impulse. Oh yeah, so I'll open that up and my phone is connected. So I don't know why it's doing that several times. Wow, this is weird. Well, I hope it doesn't really matter. So yeah, then I can navigate to the data acquisition. I will just do a small example so that you can see how to collect the data with your phone. And after that, we'll go back to the SparkFun micro mode board, and I will guide you through how to connect Edge Impulse Studio with directly this board. So here I'll do something which is really easy. So no movement. So let's say it's in the idle state. I will select one of my mobile phone sensor, which is the accelerometer that interests us here. I will sample for 10 seconds and I will click on start sampling. And you will see here, it will, okay. have a first bug. So let me delete that. Let me go back to the devices. Okay, so I do not know why. It doesn't really matter. Yes, and I will do that again. Okay, so just sampling for 10 seconds, and you should see the 3 axes like with no signal. Here we are. So basically, as the phone is just on my table here, just next to me, there is no movement. So I will just delete this sample because I really don't know why I have. Oh, I guess someone flashed the QR code as well. This is why. Okay, well, if you could please not do that, otherwise it will mess up with the project. Great. So now what I will do is connect. So first I need to delete, just quit that. And I will need to quit this serial monitor, and I will open back this serial console, this terminal, and I will use one of the Edge Impulse data forwarder. I will clean so that I can use a new project, and I will set the frequency. So I will it should detect the frequency by itself, but I will overwrite it to just set 50 hertz like it is here. Okay.
Hey, Louis?
Email address. Yeah.
Can you zoom in a bit on your screen? Some people are having trouble reading some of the code.
Of course.
I know you have a split screen right now, but for when you're on the Edge Impulse site and such, when you're putting in code and such, could you zoom in a bit for us?
Yeah.
Cool, thank you.
Just let me quit that clear. Okay, Edge Impulse data forwarder. And I will just set as it clean and then use the frequency to 50. So Louis demo, set my password here, and I will want to connect my device. So here you can see the serial console has been detected by the CLI, the Edge Impulse CLI. And I will just need to select the Spark, the project I want the board to be connected with. So here detecting the frequency, but it will override it. And I will just set the 3 axes that I want. So ax X, ax Y, and ax Z. Okay. What's the device name? So Spark Fun Micro. Here we are, and now if we go back to devices, okay, some other phone just arrived. Okay. Just delete you guys the phones. Can you do that on your project, please? And yeah, so my board is now connected here. I will just make sure that no new data came from the phones, which is good. So now that I have my board connected, I can go to the data acquisition, select my phone, and here the fun will start. So we'll start collecting the no movements, let's say for, again, 10 seconds. Well, let's say 30 seconds. I will try to register 30 seconds of the data for at least 1 minute, I guess, of each different class, which are going to be no movements, jumping jacks, squats, and then rest. So once you have done all this exercise, you need to rest and take your breath.
Can you, sorry, Louis, Can you zoom in on this screen in particular? I think it's really just the Edge Impulse, this whole section that's kind of coming in a little small. Some people are having some trouble reading them when you're on this interface.
Okay, do you think it's better now?
Yeah, I think it's a little bit better. I think, yeah, this is much clearer. Maybe just even a little bit closer. I know it's, yep. Okay, thank you.
Yeah, you're welcome. And so, yeah, I set first the label, then the length I want to sample, and then I will start sampling. And if you want to see what actually happens at the same time on the terminal, so here it will read the raw data from the device. So here the device actually it's collecting some data. So we haven't changed the code, so it's still gathering all the accelerometer information. So yeah, few more seconds. So here we are. I will do that once again with the no movement. So as you can see, the signal is a bit messier than with the phone. It's probably because it's a bit more sensitive. So I will collect a no movement again for 30 seconds. And in the meantime, while it is collecting the data, here on the top, you can see that you have the training data and the test data. So basically, what we are actually doing at the moment is collecting our data sets. So Edge Impulse is providing all the tools for you to easily collect your data set. So first we will gather some information and some data samples in the training set. And then we will have the test data. So we will be able to test our model, if it works well, on data that has been unseen during the training. And this is important to understand. So still in the training data, now I will collect some squats. There. And I guess, Casey, you can change the recording. You can see me doing some sports. So start. Let's squat. Oh, I forgot to wear it. I will probably need to do that again and delete this sample. So now I'm doing the squats. Okay, so I forgot to wear the device actually at the beginning. So this doesn't really matter, and it will give me the possibility to show you something, which is the crop sample. So for example, here at the beginning, I haven't done the squats properly. So I would just remove all the first part of the data. I will just crop that, and I will collect some more data, and I will squat again for 30 seconds. Let's squat. Okay, now you can see the squats. So it's not really completely balanced, but it doesn't really matter. People ask if we can see you doing the squats with the board. Of course, so you can switch the camera on. And now, I'm not sure if you can do that, Cassie. Maybe not while I'm sharing my screen. Maybe let me unshare my screen. Yeah, so let me do another squat. So I will not be held responsible for the quality of my squats. I haven't been to the gym in a while. So let's do some other squats. Ready? So as you can see, the way I collect the data, I just attach a rope around my neck. And So the board is just, around my neck. If you collect the data another way, for example, if you attach it to your arm, the data might look different, especially for the jumping jacks. Here, the squat's not really a big deal. Okay, so I have another thing. Now I will do some jumping jacks. Jumping jacks. We'll be exhausted at the end. Start sampling. Do that. Whew. And I will need to do that another time. And I'll start sampling again. And here we are. And now I will collect the rest class and I will share back my screen. So I collect the rest because I'm exhausted. And just another one. So as you can see, it kind of looks similar to the node movement, but it's a bit messier. So the neural network will learn that and start again the rest. Here we go. No, I'm just getting some water. And you need to do that, so maybe not for 30 seconds. Usually what we put in the test data between the training data is 80% of the data in the training data and 20% in the test data. So I might not do that right away. I will maybe switch to another project after just to show you. Let me go back. So the data collection. Yeah, so we are here. I will just pause for a few questions if you have any. And we can continue straight after.
Awesome, thank you. It's great seeing a good workout of with this great data. Let's see, we have a couple questions. Let's see. Is there any custom sensors that can be used here?
Yeah, basically when you use the data or the Edge Impulse CLI tool called the Edge Impulse Data Forwarder. You can use basically any type of accelerometer. The only thing you need to format is just to put the x-axis, then a tab, then a y-axis, then a z. We have some documentation. I guess Aurélien will be able to share that in the chat on how our data forwarder, maybe you have it as well, Cassie, works. There is a link of the documentation directly, a link of the data forwarder directly in our documentation.
Great. Awesome. And then one individual asks, for arm exercises, we won't be expected to see movements for the rest of the body, right? And if so, then how do you collect data from the accelerometer for a specific arm exercise?
Yeah, this is a really good question. So as you can see, I have the border attached around my neck. So here, it's probably not a good thing, if, for example, if you want to classify push-ups, or if you want to classify, maybe even the jumping jacks, it will be way cleaner movements if you attach it to your arm, so that you will see like a fast acceleration when you put your arms up, and then you go down. So it will probably be more accurate if you attach it to your arm. Here, as you can see, mine is here, so it's going around and around. So that's why the movement will be messier. So yeah, this is the way I collected the data. If you want to do something else, it will work as well. But then just make sure your device in production will be the same way that the way you collected the data.
Very cool. Awesome. And we have another question. Are there any other different camera development boards that we can use instead of the official supported boards?
Any kind of camera should work with the Linux, although it's, I guess it's a different type of question, not really related to this workshop, if it's the camera, but you can just ask the question on the forum, and we'll get back to you.
Yeah, that's a really good resource, is that forum, and I'll put that again in the chat for that. Does anybody else have any other questions? Let's see. Let's see. I don't know if you can help with this, Louis, but someone asked, the CLI picked a COM by itself and could not validate sensor readings from device. Do we need to override the frequency?
I'm not sure I got that question right.
Yeah.
So why? Because yeah, I overrated the frequency to make sure I had exactly 50 hertz. Otherwise, it should detect it by itself. You can leave it as is.
Okay. And you guys can always check on the forums if you have any other specific questions. I'll put a link also for any CLI installation issues and data forwarding. And then we have one more question. How can you use Bluetooth sensors for getting this data? Is there a possibility to use Bluetooth for this?
Yeah, this is a really good question. Really good question. I haven't tried, but I guess you can use the serial ports of your. You should be able to just send over the data. Just make sure the frequency or the baud rate, the data rate, matches the frequency you want to use. But I guess it's completely feasible. Yeah. You just need some workaround.
Very cool. Awesome. Yeah, people are just asking about the wirelessly, that you just answered, the wireless content, if we were able to connect that. So very cool. Yeah, I don't have any other questions that I see right now, but yeah.
Yeah, great. Then we move forward. And for the BLE connection, you will see that in the very last step, where we will send the inference results over BLE. But I guess you can as well collect some sensor data directly using the BLE. So, okay, now that we have our data set here, I will just go through all the default parameter. You will see that the model will be all right, but not completely great. And then we will go through a few tips so that you can improve your model. So first thing you need to do is to create an impulse. So we'll leave these default parameters. Then we will need to add a specific processing blocks. Basically, what the processing block will do, it will generate meaningful features so that they can then be passed to the neural network, and it will be easier for the neural network to learn. So here in our case, we'll choose the spectral analysis. If you just read through the description, great for analyzing repetitive motion, such as data from accelerometer. Okay, so that's definitely our thing. So here we click on this spectral analysis DSP block, and then we will add a learning block, which in our case will be the neural network using Keras. Note that we have as well k-mean anomaly detection and regression if you want to make some prediction. But here we will need some classification, so we'll use the neural network. And the output of this neural network will be 4 classes, whether they are jumping jacks, no movements, arrest, or squats. So we'll save this impulse, and then we will generate the features. So as I said, we will just leave the default parameters just to start with, and then we'll click on Generate Features. And once the features will be generated, you will have you will see a 3D visualization of all your steps of your data sample. And if you can distinguish some clusters, it means that it will be easy. So here, for example, we can directly distinguish 4 clusters, including the no movement here, that is kind of alone. But otherwise, you have all the rest, all the squats, and all the jumping jacks. Obviously, jumping jacks, it's a bit messier. So knowing that, it means like it will very likely be able to recognize, the neural network will very likely to be able to learn fast and have a good results. So okay, now we navigate to the neural network classifier. Again, we will just get trained with the default parameters. I just click on Start Training. So if you're not really familiar with machine learning, here you have the number of training cycles, also called the epochs. Here you have the learning rate, meaning how fast the neural network will learn. And this is a minimum confidence rating, so it will consider data that as one data that is classified accurate if it's above 60% or 0.6. And here we have a very simple architecture, which is one dense layer of 20 neurons and another dense layer of 10 neurons. So here the learning has been done, and now we're saving the best model, and we are profiling for the best compilation possible, for the best optimization possible. And you will have 2 different models, I guess, with this first version. So here, we have 53 accuracy using the quantized version, so it's not great at all. And then if we check the unoptimized, so the float 32, we have a way better model. So I will now go through all the steps so that you can achieve a better results using the quantization, although here in this case, the difference is not really important. So based on the device we've chosen, the difference will not make much difference. I will just select the other one, unoptimized, and you see only the flash usage just taking 2K more. But again, I'm not satisfied with this quantized version of 53%. So first thing I will need to do is to go back to the spectral feature, and here you can see the axis. So the process features are kind of high. So it's always best when they are normalized, so between 0 and 1. So I've been testing with 0.01 just on the scale axis, and here if I save the parameters, I go back just to show you. Here you might have some above 1, but it will be more likely the neural network will learn. The quantized version of the neural network will work best with this parameter. So again, I will save this parameter and I will just regenerate the features. The features should be done in a few seconds. Here we are, we still have the same clusters, which is great. And now we can go back to the neural network classifier and just train again with the same architecture. In another project, I slightly modified the architecture. I will now switch to the other project, which has been fully collected. So I've collected some, I think like something like 20 minutes of data, which is way more than in this case where I have only 4 minutes of data. So to do the deployment, I will use the other model, the other project that will have some better model. So here, yeah, in the quantized version, just only changing one parameter of the DSP block, we reach 90.2% of accuracy, which is not that bad considering we have only 4 minutes of data. So I won't be able to test this model on data that has been unseen because I haven't put some data in the test set. But to do that, I will switch to the other project, which is a neural network classifier. Here, let me just check. Yeah, so here I've got a better accuracy, but I slightly modified the architecture where I used still 2 dense layers, one with 16 neurons, 8 neurons. Then I used a dropout layer, which basically randomly take off some of the features, so that it's harder for the model to train, but it's easier for the neural network or for the model to be generalized. So it can recognize, for example, a pattern that are slightly different than the model it has been trained on. So yeah, we have now a model trained, and we will be able to test the model. So the testing part is done on the test data that is not present in the other project. But here I've got some test data. So when I click on model testing and classify all, it will just go through this. So well, basically what it does, it just run the inference over all those test data. And here I've got a 100% accuracy, which is a good thing, I guess. Just one thing before we move to the deployment part, you can version this project, well, your project. And here I've got one version of this project which is public, and Cassie or Aurélien will be able to share the link. So if you have any trouble, you can always, as I said before, just fork this project and use it. Yeah, so yeah, now we've trained our model, and see, it was pretty easy. Do you have any questions before we move to the next part?
Yeah, we'll give them a second to see, since there is a slight delay, if anybody has any questions. Any questions? I'll put it in the chat as well. Okay, here's one. How do you use your phone to get live results? Continuous classification while sampling, maybe, something along those lines.
Yeah, this is a good question. So basically, you need your phone to be connected to the Edge Impulse Studio. And you need on your phone, let me share again my screen, although I'm not sure I still have it, share screen. Let me just try to do that again. So just quit that and connect my phone again, screen copy. Let's move that here. Phone is not connected, maybe. Yeah, phone connected, and then you have a button at the very at the bottom of the screen phone, which is switch to classification mode. I think if you click on that. Oh no, that is for the this is for the live classification. Then you have another possibility is to use the live classification here on the left panel, which is here. And if your phone is connected, you will be able to start sampling, and it will just run the inference over and over, run the inference on your data sample. Yeah, and otherwise, if I just go back here, if I just put my phone on the table, no movement. If I just move it around, it will probably get some jumping jacks. Just check. It's maybe not even at the same frequency. So yeah, I won't take much time on it. But, this is the idea of how it works on using your phone.
Awesome. No, that's great. And let's see, we have another one. What is the difference between the rest and no movement? Oh
yeah, that's a good question. So basically, the no movements is the idle states where the device is put on a table if it's not wear by someone. Then the rest is once you have done some exercise, you are breathing. Or for example, at the moment, let me just stop sharing my screen. I've got the device around my neck. So here is just rest, but just notice that it's not on a table. So it's on a human being and not doing an exercise.
Okay.
It's kind of the unknown pattern, but you could have also another label which is unknown, and you do something else than the different classes.
Great. Okay, and we have one more question. Is there also a way to perform offline collection of data, such as during acquisition you're not connected to the internet?
So back to the remark of how to collect some data as a CSV just before, you could do that, and you could collect all the data, save them as a CSV, and then import them back into Edge Impulse Studio. We have different ways of doing that. Let me just go back and share my screen. So I haven't shown all the different possibilities, but if you connect a new device, you have also the uploader. So basically, if you go to the uploader, it will just, well, you can select a CSV file and just import that into Edge Impulse Studio.
Awesome, that's great. Let's see, yeah, it looks like we have a couple more coming in, but I think we can move ahead, and then we'll get to more questions soon.
Awesome. So yeah, back to the very last, well, no, not the very last. So here we just done that. Now we will want to run the inference on the target. So we will first run the default Arduino sketch that is slightly modified just to be able to use the same accelerometer as we are using on this board. And then we will just do the same thing, but sending the inference over Bluetooth. So here, the tutorial link is here. Well, it's at the bottom. So if you're going to the deployment tab, you can start by selecting the Arduino library, which is what we want here because we're using the Arduino IDE. If you need to integrate that directly using Zephyr or directly on this system on chip, you can just select the C++ library, and we have also some examples to run the standalone C++ library. So here I select the Arduino library. Unfortunately, this board is not natively supported yet, so it's not present here, but it doesn't matter. We will be able to do it like that. Then I always enable the Eon compiler, which, for example, if you just toggle that, you can see the difference between RAM and flash. And so basically what the Eon compiler does, it just compile the TF Lite model one step down, so it can keep the same accuracy but just have a way smaller footprint on your device. So here I use the quantized version because now I'm happy with the quantized version, and I can click on build. Okay, so now I have this this library. Let me go back to the Arduino IDE. Well, actually, let me go back first to the here it is. No, this. Where is the folder? Oh, so it's workspace, workshop example here, and I will open the micromode NRF52 accelerometer, which is the one with the inference. The name is not really great. I guess I could rename that later, but I will open this one. So yeah, I have this sketch, Arduino sketch open. And what I will need to do, I will go through all the code details in a minute. But so this one, this library, you already have it, but this one is your library. So it might, the name might change. So what you need to do is to go to Sketch, include library, add the .zip library. So here in my case, it will be in my download and modify. Here it's the very latest that I downloaded. So I choose this one. And once I've imported this Arduino library that has just been compiled using Edge Impulse Studio, I will import that into my sketch. So I will do include library. In my case, it's that one. And you will see that the fitness classifier inferencing is here. So note that the name will depend on your project name on the Edge Impulse Studio. So if, for example, you said project 1, it will be project 1 inferencing. So I just click it here. It will be at the top. So here in my case, I just remove that one because it's already on top. Actually, I'll just remove the one on top. It will be cleaner. Yeah, so I just include now I just go through all the code so that you can understand. I could just include the same thing that as before. This is the actual Edge Impulse model that I want to include. I don't set the debug. Here, if I go over the setup again, this is the same thing as just before. Just make sure your accelerometer parameters does not change from the collected one and the one that you are going to that you want to classify. Usually, when you have a difference between the sensors that where the model has been trained on and the sensors in real life, in real conditions, that can make a difference. So just make sure you have the same parameters. And here, so this is for Edge Impulse printing. Then on the loop, what I will do is start inferencing every, well, over and over again. So first, I just allocate a buffer size, which is this line of code, and then I will do exactly the same as before when you wanted to print the accelerometer data. Just in this case, I will store that in a buffer. So this buffer will then be able to be converted into a signal from buffer. So here the information will be put in the signal, and then the signal, this is a very important, well, it's probably the most important function from the Edge Impulse SDK is the rank classifier. Well, it will get a signal pointer as an entry, and it will just fill all the information in a result buffer, a result pointer. And then you will need to print the prediction. So here it will, you will be able to get this information from the result object. So the timing of the DSP, the timing of the classification, the timing of the anomaly, but we haven't used it in this example. And then for each of the classes, so we have 4 here, which are again, no movement, rest, jumping jacks, and squats. It will print the prediction, so the classification value, which is basically a prediction. So it's a percentage. It's a it's a probability. And yeah, so let's compile that and see if it works. The compilation time can take can take a long time depending on again on your machine. On mine, I've got several things open, so hopefully it will be fast. Otherwise, I can take some questions right away if you still have some.
Yeah, we'll give them a minute since there's a slight delay. Luckily, the Edge Impulse team is answering a few of the questions that are kind of following along here. If anybody has any questions for Louis, just throw them in the chat. Let's see. I know there was a question earlier that we did not get to. Let's see if I can find it. See, can we use, I think that says EL for Bluetooth RSSI classification?
I'm not sure I got the question right.
Yeah, I'm not sure if I did too. It says, can we use EL for Bluetooth RSSI classification?
So you want to classify the signals? Maybe it's well, you can take any kind of sensors or any kind of data. Here, for example, if you have a time series of RSSI, you could do some classification.
Oh, EI is an Edge Impulse. Oh, I see. Yeah. Okay, I'm sorry about that. So can we use Edge Impulse for Bluetooth RSSI classification?
You could do that, although I haven't seen many use cases around that, but I guess it's worth the try. Go ahead.
Cool. Let's see. One person asked if they can get an Edge Impulse t-shirt. They liked your shirt.
Yeah, they are awesome.
They're pretty cool shirts. Let's see. Well, I'm not seeing any other questions just yet. Yes, we all want t-shirts. Funny. But we will have a little bit of time, I think, at the end to answer any questions that come in. I'll make sure to jot them down if the Edge Impulse team isn't able to answer something, or if it's directly towards you. But I guess we can continue and then see if there's any questions at the end.
Yeah, great. Well, the sketch is still compiling.
Oh, okay.
Oh yeah, so it's done compiling now. Let me just upload that. Well, the compilation, once it's done the second time, it goes way faster.
Cool.
So yeah, I'm just probably be done in a few seconds now. And maybe, yeah, Cassie, you can share where is the public project in case anyone has trouble. They can just fork the project.
Absolutely, yeah. I put in the GitHub, the tutorial, and everything, and hopefully we'll once we send out the recording and such to everybody, we'll have all those links included as well.
Awesome. So yeah, now let's open the serial console, and so here the device is on the table, and I'm not sure I can zoom more on that. I hope you can see it well. And let me just get, so now it's on the table. I just put it at the moment around my neck, and then I just don't touch it anymore. So here you see there is the restless. Now I will do some squats, starting. Yeah, so squats, I guess it has it pretty well, and then jumping jacks. Yeah, it gets that. Let's do some squats again. Squats, and then nothing, rest. Yeah, and I will put the device back on the table, so you will see some no movements. And here we are, no movements. So this is the classification. So you see it's working pretty well. We have 4 classes that can be really easily distinguished using the inference that runs directly on the target. You do not need to have internet connection to run this inference. This is important. All the inference is done locally on the device. And now we have that. I will just go through directly the Bluetooth low energy example, so that, well, because it can take some time to compile, and then I get your questions if you have any during the compilation. So it will take some time to compile. If you have any questions, you can just share them.
So let's see, we have one question that maybe you can help with. I'm not sure. It's a basic question. The data forwarder just printed 3 numbers, and it just assumed it is 3 sensor access. Is this some kind of protocol way of printing for this?
Oh yeah, this is a good question. It's when you, so this was during the, so let me just do that again. Oh no, because otherwise it will kill the serial port on the other side. But here you can see it. So I set manually X, X, Y, and X, Z. I was just following the prompt when I ran the data for Edge Impulse data forwarder. And yeah, it was asking what kind of sensors do you have? So X, X, Y, and X, Z. And it's basically some time series data where it just gets the information from the device and from what is printed on the serial console.
Right.
Oh, yeah, good question.
Let's see. Let's see. You did your learning with the machine hanging from your neck. If it is in a different orientation, would it confuse the learning? And is it smart enough to determine which way is down and adapt?
So again, this is a really good question. So the machine learning, well, the neural network will learn based on the data. So if you, for example, have some data where it's in one position, some data it's in other position, but they have the same label, then the neural network will be able to generalize. Maybe you would need to train a bit longer, so add more epochs or add a more robust network. So for example, on the default architecture, you had only 2 dense layers. Maybe you would need to add some other layers, add some dropout somewhere, etc., etc. But yeah, it will be able to adapt.
Nice, very cool. Let's see.
Compilation is a bit long. Maybe I can go over the code while it's finishing to compile.
Sure, yeah.
So here again, we just include the libraries. You have a new one here. I'm not sure you have it already. I can't remember because I already had it on my project. If not, you can just click again on this link here where you can have the view, and it will. I think you need to select the second one. Yeah, Arduino BLE, and you just select that one, and then you will be able to use that Arduino BLE library. Then I do not need to use this debug flag. Then I will, from the Arduino BLE, there will be an instance of the BLE service where I just create a new inference service. Here, I just have a UUID that I generated with Python, just using the DNS namespace edgeimpulse.com. You can just use that one. I think some of the IDs here are reserved, for example, for some temperature or some battery information. Then, well, those two have to be different. Here you see there is a 0, here the 1. So the inference characteristic will be a subset of the service, where I will, in this case, I will need to have the BLE be able to read and to notify, so I can see the changes in real time on my phone. And then again, I include my library. Make sure you change it according to your library name, and that it should already be present in the because you've included it. Just make sure to include it like that. Include library engine. Select yours. Then the setup is pretty much the same as before, except for the BLE part, where you just set a BLE begin, and then you set the name of the device. So here, in my case, it's TinyML Coach. You set the connection interval. I'm not really an expert in all those BLE things, but yeah, basically, if you just follow the thing, all the comments just will give you a hint on what it is exactly doing. And start advertising. Yeah, that was the first message I will send. Then I just print the BLE address if I just set the debug flag to 1. And for the loop, I just declare the BLE device. And let me just go back here. And then I just go over and over, set the data rate again. I just set the data rate here in the loop because if the device is not connected, you will see that. Well, the code is a bit longer, so I'm not going to go over everything again. But if, for example, the Bluetooth is disconnected, I decided to just power down the accelerometer just to save some battery. Yeah, and then once it's going to the loop again, so the buffer, the EI run inference, which run classifier, which is here. Then, based on the results, if it has changed between the previous results, I will just send it over BLE. So I just created a small send inference over BLE function that is at the very bottom, which will just write the inference value as a string of characters. So yeah, so here it has been uploaded. Let me just connect my phone again. Here, and I will share it to you here. And I will just open the OnRF Connect. And yeah, so here I can see the TinyML Coach. I just click on Connect here. It can take a few seconds to connect. And here I've got this unknown service, this one which is the same as the one that I've declared here, the F service here. Just click on that. And I will just so here those three arrows it will just get the information in real time. So here, for example, I've got the no movement. Let me put the thing around my neck, and you will see it will change. Have I clicked? So here, rest. Let me just check if I can get the real time thing. Oh yeah, squats. So here I'm doing some squats. Let me try to do some jumping jacks. Yeah, jumping jacks. Then I rest. I don't do anything. Rest, and then I will put the board back to the table. Up here, and you should see no movements. No movement here again. So it's actually here, and if you move around, you can see like all this information, the debug information. That was it for this tutorial. I now have some time for you if you have any questions. I hope you enjoyed this this workshop. At least I had fun doing it. Thanks a lot for watching, and I stay here for your questions.
Awesome. Great. Thank you so much, Louis. And we have a couple questions here. It says, is there any resource limitations in the Edge Impulse Studio?
Yes, there is. Well, there are. So you are limited to maximum compute, not compute time, but once you run a job, you will be limited to 20 minutes. If you encounter those limits, just get back or ask us on the forum if we can do something, and usually we will get back to you.
Great.
And you have as well on the data set you have 4 gigs, 4 gigabytes, well, 4 gigabytes limits per project. And you have a limitation of 5 projects, if I recall well. Maybe Aurélien will be able to help me on that on the chat.
Nice. Nice. Can you show them once again how to access your public projects on the Edge Impulse Studio?
Of course. Let me share my screen again. So just versioning. Let me get open public version, and here you have the link. I will give it to you, Cassie, so you can send it to the participants. And if you just click on the link, you should arrive on this very same table, and you can just clone this project. If you have an account, you would just clone the project on your Edge Impulse account, and then you can go through all the steps again, and it will be yours. So it will just clone the data, etc.
Awesome, great. And we have a question for Peter over at Nordic. Let's see. It says, one question for Nordic. Is there a library available for the ANT Plus on the board? I actually want to do some ML with data from that protocol.
Yeah, thank you. Great question. Well, for the Spartan board, I don't think there's an ANT Plus library, but if you use our NR5 SDK, we have ANT support there, and then I think you can use the library or the model from Edge Impulse and integrate that, but there's no like turnkey library that you can use ANT here, but it should definitely be possible.
Awesome, great. All right, well, I'm not seeing any other questions at this moment. Thank you so much, everybody, for coming. This will, of course, be available a recording afterwards, and we hope you enjoyed it. The recording and all of the links that had gone through all of the comments should be available afterwards, so look out for that email, and thanks again for everything. Oh, we have one last question. I hope that we have about a minute left. Hopefully you can answer it, Louis. It says, is it possible to use the Bluetooth module on the laptop and receive data from the sensors? Oh, it looks like other people are also kind of.
So yeah, I'm not really sure if there is an app for the RNRF. Or in any case, you should be able to do it. Maybe not with the RNRF app, but you can. I guess it's standard, these Bluetooth protocols. Again, I'm not the expert in that. I could get back to you if you ask the question on the forum. I can dig further.
Perfect. Awesome. Well, that is wonderful. Thank you so much, Louis. Thank you so much to both of you guys. You're absolutely wonderful, and we are so happy to have you here, and we hope to do this again sometime soon. So have a wonderful rest of your day, and we'll see you again next time. Thanks, everyone.